Hi, welcome to my crypto notification bot tutorial. In this guide, I'm going to show you how to build a simple app that watches the blockchain for an on-chain event of your choosing and sends you a message on Telegram when that event happens. That could be a deposit into some DeFi app, a trade on an NFT marketplace, or whatever else type of event you might want to look out for. Here's actually an example of a DAI token transfer notification. I'm going to teach you how to get raw blockchain event data from Alchemy. I'll show you how to process that data into a human readable format, and then we'll write the code for your Telegram bot on Replit. Let's get started. Before we begin, I'm going to need you to sign up for an Alchemy account. Like I mentioned before, we're going to use Alchemy to get raw blockchain data. Don't go straight to the site. Please use the referral link that is in the video description. This referral link won't make me any money, it will just help me track how many people actually followed this tutorial. Video views are cool, but I'm much more interested in how many of you actually build something because of these videos. Okay, so use the referral link, sign up for an account, and then we're going to jump into some blockchain data fundamentals. Our Telegram bot will process raw blockchain data to figure out when an on-chain event has happened. Obviously, to build something like that, we need to get a basic understanding of how to interpret blockchain data. We will specifically be studying EVM type data. EVM is the decentralized operating system used by Ethereum, Arbitrum, Polygon, Binance Smart Chain, and a lot of other popular chains and L2s. So you'll be able to apply what you learn here to many different places. There are different levels of depth that we can go into when working on blockchain data. We're going to start our exploration at the transaction level. Now, transactions broadly fall into a few categories: sending another user ETH or whatever the native token of that chain is, creating a smart contract, destroying a smart contract, and most important for our work today, calling a function on a smart contract. Now, smart contract functions are where all the magic happens. If I want to send somebody an ERC20 token or an NFT, I will call the transfer function on that token smart contract. If I want to make a swap on a decentralized exchange, I'm going to call the swap function on that DEX's router contract. If I want to deposit some tokens into a yield farm, I will call the deposit function on that smart contract. Now, when you're using a crypto protocol's website, you don't directly see that a function is being called on some contract somewhere when you're making a transaction, but trust me, this is how it all works in the background. Now, depending on how the contract was written, these function calls can emit what is called an event when they're executed. So, for example, when calling the transfer function of a token smart contract, a transfer event is usually emitted. And these events are stored on-chain, on the blockchain, as what are called logs. Okay, let's take a step back to remember why this is important. In this guide, we're going to pick an event log this is information that is stored on-chain. We're going to pick a log that we're interested in tracking that's tied to, an event that we're interested in. We're going to use Alchemy to watch the blockchain for when a log of that event pops up. So the next time it happens, we're going to see it. And we're going to write code that will process that raw log data into a clean Telegram message. So let's look at some examples of how to interpret logs. The logic we're going to learn here, doing this manually, will map directly to writing the code for our Telegram bot. Let's say we want to make a notification that tells us when a DAI token has been transferred, how much was transferred, and between which wallets. And we want to use the logs that get stored on the blockchain to extract that information. We always start by looking at the project's documentation. Most projects link to their documentation on their website. Looking at the DAI documentation, I can see somewhere about here that this token follows the ERC20 standard, like most tokens. And I can find a more detailed breakdown of that, of that standard's functions and events here on this page. So I'm going to open that up. And as we can see, scrolling through, there are two types of transfer functions, and both of them emit a transfer event. Scrolling down further to check out the event information, we can see that this event contains these parameters: the sender address, the receiver address, and the amount transferred. The first two are indexed. We're going to see why that's important when we look at the raw transfer log in a minute, but just remember for now that they're indexed. Okay, so I have a type of action I wanted to watch for, a transfer. I know the event that's going to be recorded on the blockchain when that action happens. Now I'm going to take a look at the logs and figure out how to convert that raw data into the kind of information that we want to see. So, the documentation usually also includes some information on the address where the contract is deployed. So I can search that address on Etherscan. I've already got that open here, save us a little bit of time. Now, looking at these transactions, they all helpfully state what method was used, and I can see right here that this is a transfer. This is exactly the type of thing that I'm looking for. So I'm going to open up that page. At first glance, there's a lot of information here. We're just going to focus on the key stuff. Now, Etherscan does a fairly okay job of translating things into a human readable format. It shows us here how much DAI was transferred, from which address to what address. And if we open the details tab, we can see that the transfer function on the DAI smart contract was indeed called in this transaction. Okay, so now we're going to open the logs and look at the raw data, the untranslated version of what happened here. So this might look a bit scary at first, right? There are so many weird byte arrays. There are words too, but when we get data from Alchemy, we're not going to see these words. We're just going to see the raw byte arrays in an ocean of other byte arrays that are related to other logs. Now, let me go on a little tangent here. Not all logs on Etherscan will show this helpful label. Sometimes, like in the case I've got open here, you'll open up the logs and there won't be any words on some of them, like this one and this one right there. And that can be pretty confusing. I mean, what does this mean? What information is it trying to share? But don't worry, there are tools to help with this. I'm going to open up OpenChain. This is a tool that was started by Sam Cizon from Paradigm, and it's really helpful for decoding this particular type of madness. If I open up the signature database, I can search signatures. Taking a look, I'm going to copy the signature of this event. Now, this is important to remember. The signature of the event is always the first topic, topic 0. So I can copy and paste that into Sam's tool. And right away, it tells us that this is a transfer event and that it has 3 parameters, 2 that are addresses and 1 that's some number. Now, this is great because sometimes, the documentation is trash and you ask the protocol team questions, they don't respond to your questions. So you don't always go in knowing what the names of these events are and how they're structured, what information they're giving. So in those cases, you just have to roll up your sleeves, find the type of transaction you're interested in on the contract's Etherscan page, or maybe even make a transaction yourself to then see, that transaction on Etherscan, and then you would decode the logs this way. So in this previous example that I brought up, I have no idea what this is, but I can copy paste the signature, topic 0, into here, and that would tell me that, okay, well, that's a swap order ID. It has something to do with a swap, and I guess this is the ID of that swap. And so I can move from there in figuring out how to, detect the type of information I want to detect. Okay, so I'm gonna pull back from my tangent that I took here. How do we translate this kind of data setup that we've got over here? So the parameters that have been indexed, the sender address and the receiver address, go into the topics. You can see that the first one is the sender, second one is the receiver. We saw that in the documentation. We can confirm that by looking at, the translated Etherscan page. This is the sender and receiver, and the parameters that have not been indexed go into the data field. So in this case, the amount is not indexed; it goes into the data field. It won't show up like this, unfortunately. It will show up when we get it raw as hexadecimal, and then we'll have to convert it into a decimal number. Another funny thing, this number looks really big. If you check out the ERC20 standard, you'll find that usually, these amounts that you get are multiplied by 10 to the power 18. There's some technical reasons for that, but the actual amount is this divided by 10 to the power 18. And that's like a pattern that you'll see a lot. Okay. Now, if we get a log, just this stuff without any words from the blockchain, from Alchemy, we will be able to tell that this is a transfer and that this amount was sent from this address to this address just by looking at the byte arrays with no other context. So let's take another step back and actually remember why we're here. We wanted to know when a DAI token was transferred and the details of that transfer. And to do that, we would watch the blockchain for logs with this signature, and we would figure out who sent how much to who using the topics in the data field. Soon, I'm going to show you how to do that with Alchemy, and we'll write code to automatically interpret data that looks just like the data over here. So let's look at one more example real quick, just to cement that knowledge. What if you wanted to watch for a different event, say a swap on Uniswap? I want to be alerted of, what token got swapped by who and what amount and what price, all of that sort of information. I go through the same process. First, I'm going to check out the documentation. I'm specifically interested in swaps, so I'm going to check out this bit of the documentation, and I'm seeing here that, there are some swap functions for if it's a single swap called exact input single and exact output single. I can see that the swap router is used, the swap router contract is used to carry out these function calls. And I'm specifically interested in, well, what's the event going to look like? I can search events, check that out. And I see that there's an event for initializing a pool, minting an LP token, and this is the one I'm interested in, a swap event that contains parameters about who's the person making the swap and what was the amount of the token that was put in and the amount of the token that came out. Uniswap documentation is great. It has all of that information in there. So, okay, I understand what's going on. I know that I want to look at the swap router, and I know the function and I know the event. So I'm going to go to the deployment addresses, part of the documentation, find the address for the swap router, and I'm going to open that up on Etherscan. Already got it open here. I want to look at a past transaction, so I'm going to click there and look at the past ones, and we already see some methods that call back to what we saw in the documentation, exact input and exact output. Let me take a look at this transaction. Familiar page, familiar function call, and I'll look at the logs to find the log that I was looking for, the log of the swap event. Now, based on what we learned before, I know how to interpret this. I know that this is a signature that will tell me that it's a swap type event. I know that the sender and the recipient, in terms of the address that was making the swap and the address that would receive the result of that swap, those are indexed. So they're going to be topic 1 and topic 2. They're in order. And I know that the rest of these parameters are not indexed, so they're going to be in the data field. Etherscan has nicely decoded it for me here, but I'm going to get it normally as this hex format. But if I convert it, I'll see that the first bit of that hex data will give me the amount of one token that was put in, the amount of another token that came out, some information about the price, some information about the liquidity in the pool, and about the tick. So, this is another example of how you can manually read raw blockchain data to get the information that you want. Hopefully that helped to, just another example to help kind of cement that process. And yeah, let's move on to writing code to automate this process now. Log into the Alchemy account that you made in the first part of the video. Just a reminder to please use the referral link that's in the video description when you sign up for Alchemy. Now, once you're in your dashboard, I want you to click through to the notify section right there. The product we're going to use today is called the GraphQL webhook. That might sound intimidating if you haven't heard those words before, but don't worry, it's a really simple concept. This webhook will accept some custom filters that we give it, and then it will watch the blockchain for new event log data that might match our criteria. And then as soon as a log that meets our criteria hits the blockchain, it will send that data to us as an HTTP request. Now, you don't really need to know what I mean by HTTP request, just know that that's a standard format that applications use to communicate on the internet. So to start, let's make a webhook for a DAI token transfer. To do that, we want to filter for two things. We will want to filter for the DAI contract address and the signature of the transfer event specifically. So I'm going to create webhook by clicking that button here. This is for Ethereum mainnet. That's exactly what I want. There's a whole structure here that kind of shows this is all the type of information that will get sent to us. But you don't need to worry about that just yet. What we want to worry about is the filter. So we're going to put the DAI contract in the contract, well, in the addresses field. The little comment shows that yes, we add smart contracts to this list. So we're going to copy paste the contract address. Got to put that right there in quotes. So that will filter for this contract address. And then we're going to filter for the topic 0, which you might remember is the topic that holds the event signature. So this topic 0 right here, if you remember from the last bit of the lesson, this is a signature that tells everyone that this is a transfer event. So that's what we filter for there. And by using these filters, we're only going to get events that meet our criteria. So with 1-2 simple edits, we've now got a webhook here that will send us the event data, the log data for new DAI token transfers. And we want to test this to make sure that it works. Very soon, we're going to be writing a simple server that will be able to receive and process data from this webhook. But for now, we're going to do a bit of a hack, and we're going to use a website called webhook.site that's specifically made for testing webhooks like this one. We can use webhook.site to receive a message from Alchemy without having to do a lot of setup. What we're basically going to do is we're going to copy this address that we get given here, and we're going to give this address to Alchemy in this field as please send information to this address. Now, for the purposes of this test, we can actually tell the webhook to send us data about transactions in a particular block. In actual practice, when we make the final app, we'll want the webhook to listen to all new blocks and send us all new information, but right now, just to see how it works, we'll just query one block. So I'm going to go to Etherscan. I'm going to pick, one transaction that has a DAI transfer. And I'm going to copy the hash of the block where this transaction occurred. So I can get that right here. This is the hash of the block, and I'm going to give it to our webhook to say, well, in this case, just send us event logs that meet our criteria that happen specifically in this block. Obviously, from the term blockchain, I'm sure you already know that transactions on a blockchain all get grouped into blocks and added onto the blockchain in groups called blocks. All right, so now we've got our webhook all set up. We're going to test it right here, send a request, and we'll be able to take a look at it. All right, so it's already come through, and here we can see the result. It tells us that in the block we provided, these were all of the event logs that matched our criteria. And, you know, there's other information there about that was the hash of the block that we shared and the timestamp of when it happened. In all of these logs that we get, we can see that the first topic, topic 0, is the signature of the transfer event, and the second and third are the sender and the receiver address. They're padded with extra zeros because the data has to be a specific length, but trust me, these are the same results you'd see in Etherscan. And same as before, the data field is the amount of token that was transferred in hexadecimal format. But you know, actually scratch what I said earlier, you don't have to trust me. You can compare what we're getting here to see with Etherscan to see that it's exactly the same. So this is the transaction that I used before to pick the block that we asked Alchemy for, so we can compare what we're seeing here to what we're seeing here. I think it will be this one. So we can compare and we can see that, oh, in this log, the sender was DD72. Here, the sender is DD72 and the receiver was 71C. Here, the receiver was 71C. We can also compare and see that's the same amount. So yeah, really what you're getting is exactly the type of data that we were seeing and manually interpreting on Etherscan before. But now, you know, you can get it in an automated way and do stuff with it in an automated way. And that's what makes this really interesting. Alchemy will send us a data structure like this at every new block. So if the block doesn't contain any logs that meet our criteria, then this logs field will just be empty. And we can filter by more than just the first topic. We can also include other topics in our filter. So if I only want to get logs where the topic 1 is this, so in this case that means that the sender of the transfer is this person, I can add that to the GraphQL statement. So I can copy that, can come here, can add it as another element in the filter, and I can run another test. And we can see that we've gotten a new result right here. In the new result, we see that only the log where topic 0 was the transfer signature and topic 2 was the sender address that we gave to Alchemy. You can see that's the exact same one. Only the log that matched this criteria was sent. Other ones that didn't match this criteria weren't sent. Hopefully you can see how you could adapt this to other events. For example, sending yourself logs of Uniswap events where a specific token was swapped by adding all of the right topics here. You know, apart from kind of this raw log information, we also get other information about the transaction where the log happened, like, you know, the gas price and the contract address that was interacted with and other such things. But we can really get most of the information that we want by just looking at the logs in the way that we've been doing this whole time. So now we know how to set up the Alchemy custom webhook to send us data on a particular type of log that's emitted from a particular contract. And moving on, we're going to ditch this webhook.site page and write up our own server that can receive data from the webhook and process it into a Telegram message. Now, you can edit the criteria that we looked at here to filter for another type of event, but I'm going to keep running with this die transfer example for now. We finally arrived at the fun bit, actually going ahead and building our Telegram app. The language that we're going to use is Python, and we're going to be using Flask, which is a popular framework that makes it really easy to build web applications and APIs. Flask has all the functionality we'll need to receive HTTP requests from Alchemy and respond to those requests. We're going to write and host this app on Replit. Replit is an amazing platform that lets you write code and run code in your browser. So the first thing I'm going to need you to do is sign up for Replit, which basically looks the same as anywhere else. When you're done, here's what your homepage will look like. And once you're in here, I want you to go into the link in the description for the notifications project and open that up. I've already got it open here in a new tab. That will bring you to a page that looks like this. What we're going to do is we're going to go ahead and fork this project to make our own copy that we can edit and save and really make our own. I'm just going to open that up. Great. And now that that project's booted, we can see all of the code laid out. I'm going to walk you through this project step by step. There's only one file here that's actually important. That's the main.py Python file. Those other files are really just for handling dependencies. Right, so the first statements that we have here are for importing the Flask and Telegram API packages that we're going to need. Then we've got a statement that creates our Flask app. These next lines are for setting up the interface for communicating with our Telegram bot. We basically need to give it, in this bit here, we need to give it a unique key that grants a control of the Telegram bot. Soon I'll show you how to create a new bot on the Telegram side and get the key for it. Now for safety reasons, we don't just copy paste that key out in the open where everyone can see it. We store it secretly in an environment variable that's called bot token, because anyone who has the key for our bot would be able to take control of that. Next up, we've got a statement for creating a variable which will hold the ID of the specific chat thread where we talk to our bot, that specific conversation. Next, we write the handler where really most of the magic happens. This is the actual bit of the code that receives and processes the raw data that we get from Alchemy. Now, a lot of the logic here is specifically written for the DAI token transfer use case, but you can edit it to fit any other event use case that you'd like. So here's a breakdown of what happens. The Alchemy webhook will send a request to this notify endpoint, a request that looks a lot like the data that we saw on webhook.site. And then the handler logic will extract information from what Alchemy sends us. To kind of explain what this line means, I can open up what we saw before on webhook.site. Basically, what's happening is that that line of code is going to get the body of our message from Alchemy and take everything from the event section, and out of that, take what's in the data section, reach into that, take out what's in the block section, and finally reach into the block section and get out the logs data, which is what we actually want. So all of those steps here, that's what it's doing. It's going down the levels to specifically take out the logs data, which is what we want to mess with. That's what that line does. Then we've got an if statement here. Basically, Alchemy is going to send us data every block, regardless of whether or not there are logs in that block that meet our criteria. So sometimes there'll be blocks on the blockchain that don't have any events that meet our criteria, and Alchemy will just send us an empty data structure in that case. So when the logs array is empty, we'll just note that and move on. But when there is data in the logs array, so there were logs that met our criteria, then we're going to loop through them and apply the logic here. For each log, what we're going to do is we're going to save the sender address, which we know to be topic 1, and the receiver address, which we know to be topic 2. There's logic there for getting rid of the extra zeros, and we will save the amount which we know to be in the data field. Just an extra line there that I'm going to want to add. I'm going to divide that by 10 to the power 18 because you might remember I was mentioning in the documentation, it was talking about how, the amount that we get is actually multiplied by 10 to the 18. So what we're going to do next is we're going to craft a message with those 3 data points that, address A sent this amount of die to address B. With this if statement right here, if the user has started the chat with the chatbot, then the user will be sent a message. And if the chat hasn't been started, the chatbot will just note this information and move on. Finally, with this line here, we're gonna respond to Alchemy with a 200 status to let Alchemy know that we got their message okay. If Alchemy doesn't get this 200 status, it will just keep retrying to send us the message, assuming that something failed along the way. This statement here is a pretty simple one. The bot waits for you to send it a message that looks like /start, and once it gets that message, it knows that this is the chat thread it should use to talk to you, and it saves the ID of that chat thread. It also sends you a message to recognize that the conversation has begun and it's time to start sending notifications. These statements right here, they basically set up the app to listen for new messages on Telegram, and this final statement actually starts the Flask app when you run this script. And that's a wee breakdown of how the code here works. Next up, we're going to create a new bot on the Telegram side, link it to the server by giving the server its special API key, and start to see some of those messages roll in. Alright, so first things first, we have to set up a new Telegram bot on the Telegram side. How we do that is that we go to the regular messaging app, and we're going to message a handle called the botfather. So the handle is @botfather. This is Telegram's tool for creating all new bots. And we just have to message the botfather the new bot command to get started creating a new one. I'm going to call our bot crypto notifications Python. Gonna call it that, and then I need to give it a username, crypto notify pi_bot. Name has to end with bot, and that's it. We've created a new bot on the Telegram side, and it's given us our key that grants control. It's not really good security practice for me to be showing you this. Usually you should never show anybody this key, but just for the sake of this tutorial, I'm being a bit sloppy. Now, in my project, I'm going to save this key in an environment variable called bot token, like we talked about before. To do that, I'll use the secrets tool to create that secret. So the name of the secret will be bot token, and the value will be what was given to us by the botfather. So we add that new secret. You can see that it's saved in there now, and that the environment variable of the same name should be able to get access to it. Okay, now that that's set up, we can go ahead and run our server, bring it to life. Very simple first step. You just press run here to run our Flask project. Should be able to see in console that that works okay. Yes, so that's live now. The next step is to set up our webhook. So we're going to go into Alchemy, we're going to create the webhook. We're going to add the filters that we did before. So I need to search up the DAI token contract so I can copy the contract address again. I'm going to copy that, put that in the address filter. And then I need to copy the topic 0, the signature for a transfer log. That's always the first one right here. I'm going to copy that. So same as before, for the DAI contract and for transfer logs. Okay, so that's good. Now I'm going to copy in the address that it should be sending information to. In this case, if you see in this web view tab, this is the link for communicating with our REPL. It's in the format, the project name, .yourusername.repl.co. I'm going to copy that into here, and I'm going to add to the end /notify. Because if you remember, we wrote our project in such a way that /notify is the endpoint that handles receiving and processing data. So that's where it comes in. All right, so everything looks good. That's for Ethereum mainnet. I can go ahead and create my webhook. My webhook is now active. All right, so now the server is live and the webhook is live. So I'm just going to go ahead and start the bot on the Telegram side. If you remember, the way that we start the bot is by, initiating the conversation. The bot father gives us the link to our notify bot. So I'm just going to click that and press start. It's been given that /start command. It is telling us we will now receive notifications, and we'll probably just have to wait a minute for some notifications to start rolling in. People are transferring DAI all the time. So this is an example where you'll get a lot of results really fast. If it was a less common event, then you'd have to wait longer. Great, so we're already starting to see some notifications coming in that this wallet sent 6,000 DAI to this other wallet, and these are just going to keep rolling. I hope that, that feels a bit satisfying. I know we've gone through a lot of content, but right now at this moment, you've got a live notification bot that will just keep pinging you on Telegram whenever something interesting happens based on what you decided. Now, a few housekeeping things to take into account. Right now, this webhook is live, but because this is just the test, I'm not actually using the bot day-to-day right now. I should deactivate it in order to save my free Alchemy credits. I have a certain number of free Alchemy credits and more notifications coming in. I have a certain number of free Alchemy credits, and if those run out, then I'd have to go into a paid plan. So I'm going to deactivate this for now since I'm not using it. If you're not using a webhook, please do deactivate it, or even just delete it if you're not going to use it again. And another thing, on the Replit side, this bot will only be live as long as you keep this tab open. If you want it to be live all the time, there's this always on option for keeping the Replit awake. But unfortunately, that's not free. It costs a number of credits a day. Based on like Replit's pricing plan, I think it's actually it comes out to be very cheap. I think it's like $7 a month or something like that if you wanted to keep it live for the month. So yeah, if for simple testing, you can just keep this tab open and it will be live as long as the tab is open. But if you wanted to stay always on and always operational, then you'd need to follow through on that. So yeah, that is us with our live Telegram bot. Congratulations again on making it this far. Alright, so now you know how to build a Telegram notification bot that will alert you when an on-chain event has happened. You had to wade through a ton of new information to get here, so you've been really patient and you've done an amazing job. We've walked through the basics of reading raw blockchain event data, setting up an Alchemy webhook to send us raw event data, and writing a Python app that accepts the data from Alchemy to craft it into a Telegram message. We've crossed a lot of ground, but I hope that this is kind of just the start for you. I focused on the transfer event of the DAI token for most of this tutorial, but you should definitely try reading the event data for another event you're interested in on another protocol that you are a fan of, and make a bot for that event. If you're stuck on the Python side of things, any problems there, you can use ChatGPT probably to help you edit the script however you'd like. If you're stuck when it comes to understanding blockchain data, drop a comment. I'll try my best to answer any questions that appear in the comments, or come see us in the Alchemy Discord to get your questions answered. And yeah, thanks a lot for taking the time to run through this lesson. Please let me know on Twitter what you thought, whether it needed more explanation, less explanation, what you'd like to learn to make next, and any other feedback there. Yeah, can't wait to see all of the cool stuff that you guys make. I'll catch you next time.